Section 1. The straight line. Many modern wireless systems need a clear path to work properly. This direct path is known as line of sight. It means the sending antenna and the receiving antenna must be able to see each other. There can be no large obstacles in the way. For high-frequency signals, this is a fundamental rule. FM radio, television broadcasts, cell phones, Wi-Fi. These signals travel in very straight lines. They do not easily bend around the curve of the Earth. They do not pass through hills or large buildings very well. This physical limitation is a constant challenge for engineers and planners. To overcome this challenge, height is the most powerful tool. A tall tower, a high mountain. The signal can travel much farther before the Earth's curvature blocks its path. This is the simple reason why broadcast towers are built as tall as possible. It is also why cell phone towers are often placed on hilltops or the roofs of tall buildings. A higher starting point creates a longer, clearer line of sight to the horizon. This allows a single transmitter to cover a much wider area with a strong and reliable signal. The logic is ancient. Height gave line of sight for smoke and signal fires. Today, radio replaces visible light. During the Cold War, the United States military and scientific community had an urgent need to understand radio waves. They needed to create reliable and secure communication systems. They also needed to build advanced radar to detect incoming threats from far away. To do this, they moved beyond theory and conducted real-world experiments. The goal was to learn precisely how radio signals traveled through the atmosphere over long distances. They needed to understand how weather, terrain, and the Earth's own atmosphere affected these signals. This required large-scale, outdoor laboratories. Mountains provided the ideal setting, long, clear line-of-sight paths for high-frequency testing. Scientists placed powerful transmitters on peaks and receivers at various distances on the plains below. They logged signal strength, fading, and interference at scale. These were major undertakings with sophisticated equipment and significant government funding, part of a technological race. Focusing on VHF and UHF, the data-informed radar networks like the DEW line, better aircraft comms, and reliable secure links. Two specific locations in Colorado became central to this Cold War radio research: Pikes Peak, Cheyenne Mountain. Their proximity to research in Boulder and Denver, combined with immense height, made them natural laboratories. In the 1950s, the National Bureau of Standards, later NIST, established a major field station on Cheyenne Mountain slopes. It was selected for commanding views and unobstructed paths over the eastern plains for long-distance experiments. Researchers installed powerful transmitters and sensitive receivers to study propagation across wide frequencies, emphasizing VHF and UHF crucial to radar and military comms. Signals were sent to mobile receiving stations hundreds of miles away in Kansas and Nebraska. By tracking distance, weather, and time of day, they modeled how waves traveled beyond the visible horizon. This was practical, empirical science. Pikes Peak's greater elevation supported numerous temporary summit experiments, simulating high aircraft paths and all-azimuth tests. It enabled air-to-ground testing and atmospheric effects studies. Their data improved radar reliability, seeded troposcatter networks, and reinforced Cheyenne Mountain's selection for NORAD. Geology first, but also a proven strategic perch for long-range sensing and communications. Today, the term directed energy has entered the public conversation. A directed energy weapon uses focused electromagnetic energy to disable, damage, or destroy a target. Unlike a projectile, a bullet, or a missile, it delivers energy directly. Energy can be carried by photons or other subatomic particles. The two most common types are high-energy lasers and high-power microwaves. A high-energy laser produces an intense, narrow beam of light. On impact, it rapidly heats the surface. With enough power and dwell time, it can burn through metal, disable sensitive electronics, or detonate explosive material. The beam travels at light speed, enabling engagements of drones, mortars, even missiles. High-power microwaves project a powerful, focused RF beam. Instead of heat damage, they overwhelm or destroy electronic components. A non-kinetic effect. Both HEL and HPM require line of sight. Terrain and even heavy weather can block or weaken the beam. The physical principles connecting Cold War radio tests and modern directed energy systems are direct and unambiguous. The unifying concept is the absolute need for a clear line of sight. 1950s radio teams climbed mountains to extend signals. Modern DEWs also seek high ground. Pikes Peak's tropospheric scatter history shows why the same location benefits long-range energy projection. Communications can tolerate weak signals. DEWs cannot. Spread and absorption kill mission effects. To burn a drone skin or disable missile guidance, you need a clear, unobstructed path. High altitude minimizes haze and extends the geometric horizon, from a few miles on the ground to over 100 miles at 14,000 feet. From peaks, systems gain wider fields of view and longer unobstructed shot paths. The Cold War sent information from A to B. The modern designer sends destructive force, both bound by LOS, attenuation, and Earth's curvature. The work on those peaks still informs long-range energy projection today. We must now address a more difficult question. Is it technically possible to aim directed energy at specific individuals from high-altitude sites? From a physics perspective, yes, the technology exists. The active denial system uses a millimeter wave beam around 95 GHz, focused on human-sized targets to cause intense but temporary pain. High peaks offer secure sights, reliable power, and commanding line of sight. Cheyenne Mountain exists and retains those strategic advantages. However, technical possibility is not proof. There is a critical lack of public, unclassified evidence of targeting non-combatant individuals from mountain sites. Public records show DEWs focused on military missions, counter-drone, ship defense, and missile defense. Separate what we know from what we do not, the story is defined as much by evidence we have as by evidence we lack. Thanks to Thunderbird Perch for making this video possible. Thank you for watching. If you enjoyed this video and want to learn more, please like, share, and subscribe for more.